Here we are going to determine whether two sets are equivalent to each other. And for two sets to be equivalent to each other, they must have the same cardinal number of elements. So for A here, we have set C has the elements 7 of hearts, ace of hearts, 10 of clubs, and the 5 of diamonds. And then this set G over here has the 2 of spades, the 5 of hearts, the 3 of diamonds, and the 7 of clubs. So the cardinal number for set C here is 4, and the cardinal number for set G here is also 4. And you can see that none of the elements in C is the same as the elements in G, but they have the same cardinal number. So since they have the same cardinal number, they're equivalent to each other. So the symbol for equivalency is this. So I'm just going to write it like this. So they are equivalent to each other. Now keep in mind that sets that are equal to each other are automatically equivalent to each other. So here we have B. We have a set here that's got the cardinal number of 3. It's got Greg, Peter, and Bobby. And then we have another set here that's also got a cardinal number of 3. It's got Marcia, Jan, and Cindy. So these two sets are equivalent to each other. So for C, we have this set here. It says set E is the set of elements E, such that E is an element of the natural numbers. That's the counting numbers. And E is an even number between 200 and 300. And then we have set O is the elements O, such that O is an element of the natural numbers. That's the counting numbers. And O is an odd number between 200 and 300. Now, if we include the number 200 and 300, then the cardinal number for E is going to be 51. If we do not include 200 and 300, because it does say, after all, between 200 and 300, so it's a little disambiguous. So if we were to think that 200 and 300 is not included, then the cardinal number for this set would be 49. For O, there's no disambiguousness at all going on. The cardinal number for O is going to be 50. Either way, if we include 200 and 300, or if we don't include 200 and 300, either way, these two sets are not equivalent to each other. So I'm just going to put the equivalency sign with a line through it. So they're not equivalent. For D, we have 19, 20, and 34. And for here, we have 20, 34, and we have the empty set here. But the cardinal number for this set here is 3, and the cardinal number for this set here is also 3. So these are equivalent sets. And finally, for D, we have 0, 6, 12, 18, 24. A pattern has been established. And then we have this ellipses here, 90 and 96. And the set of positive integers less than 100 and divisible by 6. So we have this roster method that shows this set here. And then we have a word description here, but they're both describing the same set of numbers. So these are actually equal to each other. And when two sets are equal to each other, they're also automatically equivalent to each other. And there you go.